Picture this, a machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, it picks up the keywords play and Despacito, and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that by the year 2045, we would have robots as smart as humans. This is called the point of singularity. Well, that's not all. In fact, Elon Musk predicts that the human mind and body will be enhanced by AI implants, which would make us partly cyborgs. So, here's a question for you. Which of the below AI projects don't exist yet? A. An AI robot with citizenship. B. A robot with a musculoskeletal system. C. AI that can read its owner's emotions. D. AI that develops emotions over time. Give it a thought and leave your answers in the comment section below. Since the human brain is still a mystery, it's no surprise that AI too has a lot of unventured domains. For now, AI is built to work with humans and make our tasks easier. However, with the maturation of technology, we can only wait and watch what the future of AI holds for us.
By the end of this lesson, you will be able to define artificial intelligence, describe the relationship between artificial intelligence and data science, define machine learning, describe the relationship between machine learning, artificial intelligence, and data science, describe different machine learning approaches, identify the applications of machine learning. Let's understand how the field of artificial intelligence emerged. Let's first understand the reason behind the emergence of AI. Data economy is one of the factors behind the emergence of AI. It refers to how much data has grown over the past few years and how much more it can grow in the coming years. When you look at this graph, you can clearly understand how the volume of data has grown. You can see that since 2009, the data volume has increased by 44 times with the help of social websites. The explosion of data has given rise to a new economy, and there is a constant battle for ownership of data between companies to derive benefits from it. Now that you know that data has grown at a rapid pace in the past few years and is going to continue to grow, let's understand the need for AI. As you know, the increase in data volume has given rise to big data, which helps manage huge amounts of data. Data science helps analyze that data. So the science associated with data is going toward a new paradigm where one can teach machines to learn from data and derive a variety of useful insights, giving rise to artificial intelligence. Now, you may ask, what is artificial intelligence? Artificial intelligence refers to the intelligence displayed by machines that simulates human and animal intelligence. It involves intelligence agents, the autonomous entities that perceive their environment and take actions that maximize their chances of success at a given goal. Artificial intelligence is a technique that enables computers to mimic human intelligence using logic. It is a program that can sense, reason, and act. Let's look at some of the areas where artificial intelligence is used. Artificial intelligence is redefining industries by providing greater personalization to users and automating processes. One example of artificial intelligence in practice is self-driving cars. Self-driving cars are computer-controlled cars that drive themselves. In these cars, human drivers are never required to take control to safely operate the vehicle. These cars are also known as autonomous or driverless cars. Let's see how Apple uses AI. iPhone users can experience the power of Siri, the voice. It simplifies navigating through your iPhone as it listens to your voice commands to perform tasks. For instance, you can ask Siri to call your friend or to play music. Siri is fun and is extremely convenient to use. Another example is Google's AlphaGo, which is a computer program that plays the board game Go. It is the first computer program to defeat a world champion at the ancient Chinese game of Go. Amazon Echo is another product. It's a home-controlled chatbot device that responds to humans according to what they are saying. It responds by playing music, movies, and more. If you've got compatible smart home devices, you can tell Echo to dim the lights or turn appliances on or off. You can use AI in chess, and here is an example of a concierge robot from IBM called IBM Watson. The IBM Watson AI has typically been in the headlines for composing music, playing chess, and even cooking food. Let's move ahead and look at some sci-fi movies with the concept of artificial intelligence. The films featuring AI reflect the ever-changing spectrum of our emotions regarding the machines we have created. Humans are fascinated by the concept of artificial intelligence, and this is reflected in the wide range of movies on AI. Recommendations systems are used by a lot of e-commerce companies. Let's see how they work. Amazon collects data from users and recommends the best product according to the user's buying or shopping pattern. For example, when you search for a specific product in the Amazon store and add it to your cart, Amazon recommends some relevant products based on your past shopping and searching pattern. So before you buy the selected product, you get recommendations based on your interest And there is a possibility that you may also buy the relevant product with the selected product. If not, you have the chance to compare the selected product with the recommended products. Now let's move ahead and understand the relationship between artificial intelligence, machine learning, and data science. Even though the terms artificial intelligence, AI, machine learning, and data science fall in the same domain and are connected to each other, they have their specific applications and meaning. Let's try to understand a little about each of these terms. Artificial intelligence systems mimic or replicate human intelligence. Machine learning provides systems the ability to automatically learn and improve from the experiences without being explicitly programmed. Data science is an umbrella term that encompasses data analytics, data mining, machine learning, artificial intelligence, and several other related disciplines. Let's look at the flow diagram and try to understand the relationship between AI, machine learning, and data science. Interestingly, ML is also an element of artificial intelligence. So the first step is data gathering and data transformation. This step basically comes under data science. Data transformation is the process of converting data from one format or structure into another format or structure. Data transformation is important to activities such as data management and data integration. After gathering data, we would want to use the data to make predictions and derive insights. In order to get predictions out of the data set, we use machine learning techniques such as supervised learning or unsupervised learning. On an overview level, supervised and unsupervised learning are the machine learning techniques used to extract predictions from a given data set.
Now you must be thinking where deep learning comes into the picture. Deep learning is a subfield of machine learning involved with algorithms. It uses artificial neural networks, which are modeled on the structure and performance of neurons in the human brain. Deep learning is most effective when there isn't a clear structure to the data that you can just exploit and build features around.
Now, the next step in the flow diagram is to get insights from predictions being made. In order to do so, you need to use data analysis, which actually is the process under data science. Now, when you are done with all of these, you must want your data to perform some actions. This is where AI comes into the picture. Artificial intelligence combines predictions and insights to perform actions based on the human decision and automated decision. Now, let's move ahead and understand the relationship between artificial intelligence, machine learning, and data science. Let's look at the relationship between artificial intelligence and machine learning. Artificial intelligence is the engineering of making intelligent machines and programs. Machine learning provides systems the ability to learn from past experiences without being explicitly programmed. Machine learning allows machines to gain intelligence, thereby enabling artificial intelligence. Let's now understand the relationship between machine learning and data science. Data science and machine learning go hand in hand. Data science helps evaluate data for machine learning algorithms. Data science covers the whole spectrum of data processing, while machine learning has the algorithmic or statistical aspects. Data science is the use of statistical methods to find patterns in the data. Statistical machine learning uses the same techniques as data science. Data science includes various techniques like statistical modeling, visualization, and pattern recognition. Machine learning focuses on developing algorithms from the data provided by making predictions. So, what is machine learning? Machine learning is the capability of an artificial intelligence system to learn by extracting patterns from data. It usually delivers quicker, more accurate results to help you spot profitable opportunities or dangerous risks. Now, you must be curious to understand the features of machine learning. Machine learning uses the data to detect patterns in a data set and adjust program actions accordingly. Pattern detection can be defined as the classification of data based on knowledge already gained or on statistical information extracted from the patterns. It focuses on the development of computer programs that can teach themselves to grow and change when exposed to new data by using a method called reinforcement learning. It uses external feedback to teach the system to change its internal workings in order to guess better next time. It enables computers to find hidden insights using iterative algorithms without being explicitly programmed. Machine learning uses algorithms that learn from previous data to help produce reliable and repeatable decisions. It automates analytical model building using the statistical and machine learning algorithms that tease patterns and relationships from data and express them as mathematical equations. Let's understand the different machine learning approaches. So, what is the actual difference between traditional programming and machine learning? In traditional programming, data and program is provided to the computer. It processes them and gives the output. However, the machine learning approach is very different. In machine learning, algorithms are applied on the given data and output. The result of the applied algorithm and calculations is a learning model that helps machine to learn from the data. In traditional programming, you code the behavior of the program, but in machine learning, you leave a lot of that to the machine to learn from data. Now, let's first understand the traditional programming approach. Traditionally, you would hard-code the decision rules for a problem at hand, evaluate the results of the program, and if the results were satisfactory, the program would be deployed in production. If the results were not as expected, one would review the errors, change the program, and evaluate it again. This iterative process continues till one gets the expected result. What is the machine learning approach? In the new machine learning approach, the decision rules are not hard-coded. The problem is solved by training a model with the training data in order to derive or learn an algorithm that best represents the relationship between the input and the output. This trained model is then evaluated against test data. If the results were satisfactory, the model would be deployed in production, and if the results are not satisfactory, the training is repeated with some changes. Machine learning techniques. Machine learning uses a number of theories and techniques from data science. Here are some machine learning techniques: classification, categorization clustering, trend analysis, anomaly detection, visualization, and decision-making. Let's look at these techniques. Classification is a technique in which the computer program learns from the data input given to it and then uses this learning to classify new observations. Classification is used for predicting discrete responses. Classification is used when we are training a model to predict qualitative targets. Categorization is a technique of organizing data into categories for its most effective and efficient use. It makes free text searches faster and provides a better user experience. Clustering is a technique of grouping a set of objects in such a way that objects in the same group are most similar to each other than to those in other groups. It is basically a collection of objects on the basis of similarity and dissimilarity between them. Trend analysis is a technique aimed at projecting both current and future movement of events through the use of time series data analysis. It represents variations of low frequency in a time series, the high and medium frequency fluctuations being out. Anomaly detection is a technique to identify cases that are unusual within data that is seemingly homogeneous. Anomaly detection can be a key for solving intrusions by indicating a presence of intended or unintended induced attacks, defects, faults, and so on. Visualization is a technique to present data in a pictorial or graphical format. It enables decision makers to see analytics presented visually. When data is shown in the form of pictures, it becomes easy for users to understand it. Decision-making is a technique or skill that provides you with the ability to influence managerial decisions with data as evidence for those possibilities. Now, I am sure you have a better understanding of the overview of machine learning, so let's look at some real-time applications of machine learning. Artificial intelligence and machine learning are being increasingly used in various functions, such as image processing, robotics, data mining, video games, text analysis, and healthcare. Let's look at each of them in more details. So what is image processing? It is a technique to convert an image into a digital format and perform some operations on it so as to induce an enhanced image or to extract some helpful information from it. Let's look at some of the examples of image processing. Facebook does automatic face tagging by recognizing a face from a previous user's tagged photos. Another example is optional character recognition, which scans printed docs to digitize the text. Self-driving cars are another big example of image processing. Autopilot is an optional drive system for Tesla cars. When autopilot is engaged, cars can self-steer, adjust speed, detect nearby obstacles, apply the brakes, and park. Now let's see how robotics uses machine learning. Robots are machines that can be used to do certain jobs. Some of the examples of robotics are where a humanoid robot can read the emotions of human beings, or an industrial robot is used for assembling and manufacturing products. So let's look at some real-time applications of machine learning. Let's see what data mining is. It is the method of analyzing hidden patterns in data. Let's look at some of the applications of data mining. It is used for anomaly detection to detect credit card fraud and to determine which transactions vary from usual purchasing patterns. It is also used in market basket analysis, which is used to detect which items are often bought together. It can be used for grouping, where it classifies users based on their profiles. Machine learning is also applied in many video games in order to give predictions based on data. In a Pokemon Go battle, there is a lot of data to take into account to correctly predict the winner of a battle. And this is where machine learning becomes useful. A machine learning classifier will predict the result of the match based on this data. Let's move on to one of the most popular applications of machine learning, which is text analysis. It is the automated process of obtaining information from text. One example of text analysis is spam filtering, which is used to detect spam in emails. Another example is sentimental analysis, which is used for classifying an opinion as positive, negative, or neutral. It detects public sentiment in Twitter feed or filters customer complaints. It is also used for information extraction, such as extracting specific data address, keyword, or entities. There are many applications of machine learning in the healthcare industry, identifying disease and diagnosis, drug discovery and manufacturing, medical imaging diagnosis, and so on. Some of the companies that use machine learning have revolutionized the healthcare industry are Google DeepMind Health, BioBeats, Health Fidelity, and Ginger.io.
What's interesting to me is we will use AI, as we have been, to specifically target tasks that we need or want done in place of ourselves. That's how AI will ultimately unfold.
It is a renaissance. It is a golden age. We are now solving problems with machine learning and artificial intelligence that were, kind of in the realm of science fiction for the last several decades.
AI is probably the most important thing humanity has ever worked on. I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides.
We're focusing on autonomous systems. And clearly one purpose of autonomous systems is self-driving cars. There are others. And we sort of see it as the mother of all AI projects.
So there's a class of things like game playing or speech recognition or image recognition that the performance levels are phenomenal. You know, if you compare human speech recognition to computer speech recognition, the computer is slightly better. And that's, you know, mind-blowing. Certainly we use AI to do drug discovery. These biological systems are very complicated. And so the fact that we have vaccines for TB and HIV coming, that's partly enabled by this rich data, advance in biology, and machine learning.
When I look at Seeing AI, which is an application we just launched for anybody with visual impairment, they can go download this app that uses the latest cutting-edge computer vision technology in our cloud to give anyone the ability to see. And in fact, Angela Mills, who's a colleague of mine, was just telling me about how it's changed her life inside of Microsoft. She can go into our cafeteria, order food using this app with confidence, walk into conference rooms with confidence because she knows she's walking into the right conference room. Or what we've done with our OneNote and Word learning tools. Anyone who has dyslexia can now use AI to be able to read better. The latest release of Windows 10 has this capability called eye gaze, which is something that we learned working with Steve Gleason and the ALS patients, to saying, if all you have is the eye muscle and the gaze, can we help you type?
Yeah, you have to be careful when there's advances. In a sense, we're all better off. If the machines can make all the food and the clothes and none of us have to work, you think, okay, now we have all the freedom. If we want to stand behind the counter and make sandwiches, okay, you can if you want, but there's this other way to make those goods and services. But it will be very disruptive because, say you're mid-career in manufacturing or driving, then it's a disruption. Now we've had that in a slow way for hundreds of years. We used to all be farmers, now very few of us are farmers.
I said it's right to be concerned, absolutely. You have to worry about it, otherwise you're not going to solve it, right? And it's important to understand tomorrow whether Google is there or not, artificial intelligence is going to progress. Technology has this nature, it's going to evolve. I think pulling back, history shows pulling back, countries which pull back don't do well with the change. We know that. 20, 30 years ago, you educated yourself and that carried you through for the rest of your life. That is not going to be true for the generation which is being born now. They have to learn continuously over their lives. We know that. So we have to transform how we do education.
Look, you nailed it. Anything that's repetitive and done on the back of, technology or, is going to be fundamentally vulnerable.
Yeah.
So I think technology, and in particular AI, can in fact bring more empowerment, more inclusiveness. And at the same time, we should be clear-eyed about displacement, clear-eyed about unintended consequences like any other technology, and work both skilling so that people can find the jobs of the future, create new jobs, and lastly, I think have a set of policy decisions that really help people as they go through this change.
But the risks are important, and I think the way we solve it is we think ahead, we worry about it, we do things like be upfront, have ethical charters, think about AI safety from day one, be very transparent and open in how we pursue progress there, and figure out global frameworks by which we can engage. Just like Paris Agreement and climate change, using forums like this, I think we bring people together to engage on the hard questions, and I think answers will emerge.
I have exposure to the very most cutting edge AI, and I think people should be really concerned about it. I keep sounding the alarm bell, but until people see like robots going down the street killing people, like they don't know how to react, because it seems so ethereal. I think we should be really concerned about AI, and I think we should. AI is a rare case where I think we need to be proactive in regulation instead of reactive, because I think by the time we are reactive in AI regulation, it's too late.
Right now we have machine learning algorithms that can solve an incredibly complex problem beyond any human intelligence, but they're essentially complete idiots and like 2-year-olds at anything that's not that problem. They're dumb. You can give them this enormous data set and they come up with brilliant correlations and insights, but they're not going to plug into Skynet and threaten us anytime soon.
So I'm quite optimistic, and I don't think artificial intelligence is a threat. I don't think artificial intelligence is something terrible, but human beings are smart enough to learn that.